find the intercepts of f of x equals, and in parentheses we have x plus 6 times x plus 1 times x minus 2 times 3x minus 1. Okay, so we see that this is a polynomial, right? And we see 4 different parentheses here, right? So we don't see any exponents either. Okay, so that tells us there are going to be 4 different x-intercepts. Okay, so what we want to do then is just set each of these factors equal to 0. Okay, so we're going to set x plus 6 equal to 0. We're going to set x plus 1 equal to 0, x minus 2 equal to 0, and 3x minus 1 equal to 0, and we'll just solve each one here, right? Here we'll subtract 6 to both sides, we get x equals negative 6. Here we get x equals negative 1. Here we get x equals positive 2. And then when we add the 1 here and divide by 3, we get x equals 1/3. So these are our x-intercepts, right? The graph will touch the x-axis at these 4 points. Okay? Now to find the y-intercept, there's only one y-intercept always, right? We just plug in 0, right? Just plug into 0 and see what we get. Okay, so I'll just write it down here, right? We get 6 times 1 times negative 2. When you plug into 0 here, we get negative 1 here, right? So we actually just get positive 12. Okay, so there's going to be the y-intercept at positive 12. Now, I know the question doesn't say to graph it, but let's do that. Okay, we should be able to graph it using the information that we know. Okay, so we're going to use the end behavior. Okay, so we're going to use the end behavior and the intercepts, and we should be able to draw a quick little sketch. Now, I should point out that it's not going to be the exact graph, okay? But it's just going to be a rough idea or a pretty good snapshot of what the graph actually looks like. Let's take a look. We know where the x-intercepts are, right? We know that there's an x-intercept here at negative 6, also at negative 1, at positive 1/3, and at 2. We also know that the y-intercept is up here. I'm just going to eyeball this one here at 12. Okay. So then the question becomes, though, right? Okay, what's happening here, right? What is the graph actually doing? Now, there's a couple things we can do here, right? We can actually plug in points. Okay? Like we can find, you don't need to do this, right? But what is f of negative 2, right? So here's negative 2. Plug it in, we can get the y value, right? F of negative 3. Right, f of 1, right, f of 3. So we can do this. We can make a table, plug in values, get those points, right, and then we should be able to get a pretty good outline of what we're doing and just connect the dots. Okay, but that we don't recommend that way, right? We recommend using the end behavior, right, and just a general knowledge of what the shape of a polynomial would look like. Now let's take a look here. If I ask you, okay, what is the degree of this polynomial? And what is the leading term, right? What would you say in this case? Okay. Well, in this case, the leading term is positive. Okay, we don't see any negatives out front, right? So we know that this is a negative, positive, okay, leading term. Okay. We also know that the degree is even, right? There are 4 distinct or unique factors here, right? Okay, so this is an even polynomial. So what does that have to do with the graph, though? Okay. So what it does is it tells us that our graph is going to be a U-shape, right? This is going to be a U-shape because it's even. Because it's positive, it's going to open up, which means we go up and to the left and up and to the right. And we're going to look something like this. But then the question is, okay, what happens in between, right? Well, these are the x-intercepts, right? We know that our graph must touch the graph here and must come back. Right? We call this a turning point. There's the next x-intercept, right? So remember, we're not going to do something crazy, okay, and loop around and have some sharp corners, okay? Polynomials are called smooth curves, okay? So we're just going to go to that x-intercept. We know that the y-intercept here, but we also know that our graph should come back down here, right? Okay, so we'll go through that point, come back down, and come back, turn around, come back to the next x-intercept, and then, well, we're going to end over here. Okay, so in this case, let's just erase this part here, okay? And we know then that our graph should be doing a little something like this. Okay? Now, once again, I want to mention this is just a rough sketch. Okay, if you actually graph this on the graphing utility, okay, it's not going to look exactly like this, but we should have the same x-intercepts, the same y-intercept, and the same end behavior.